Okay, so continuing on last week's video where we started working on the exercise, which basically is about choosing our favorite company and then and try to investigate what are the VRIN, that means the valuable asset of the company, like technology and IP wise, and then come up with new product idea. That's the exercise about. So the way we want to do the exercise is we choose the company, and then of course we go into the IP of the company, and then for to give a justice to the exercise, you need to understand. If we want to understand what is the VRIN or the valuable asset of a company, then you need to understand that what are the other companies around and compared to them. Because without knowing what are the other competitive companies, you can't really say what is the valuable or unique about a certain company. So that's why we decided that okay, so along with one company we'll also choose another company. So and then of course that's the overall structure. So last week we gone through the IP of the MI labs, and then and trying to understand the detail of it, and this week we'll start at least with you might expect that we will go into other company, but I think we should spend some time on the list of product that the ML Labs basically provides, and because without that we'll not be able to have a good sense about the product innovation and etc. IP is good, but those are more of in a conceptual level, and as I said that a lot of are actually in not in the product form, rather in tentatively future, maybe in future they will look into that. So yeah, so let's get started then. So to start with, we will basically go into the product list of MLF. So you can download their booklet or whatever name it is. It's a PDF file of, let's say, 20 or 30 pages. And so here I'm just showing how to market it is even like for example, this is the logo, and it's not important, but the writings like ultra high performance synergistic preclinical imaging. So certainly their focus is not on clinical, although we had seen one of the patent basically, which is very recent patent, and that's clinical. So in future they will certainly maybe move into that direction. We never know, but I think it's a good way to understand how to market or things, or if not understanding how to market it, but at least to see how they are marketing the thing, then we'll get more about understanding about the product. Like for example, ultra high performance. So from an user's point of view, they don't know, or conceptually most of them do not know that what are the underlying physics, or they conceptually they know, but the detail of it, nutshell, this very detail of it, they don't know. So you need to sell them this, and the booklets and all these things are actually the marketing products that you're giving information and how you're portraying it. You can't just not like in writing a paper where you start with the very technical detail, etc. You can't do that actually. So you need to understand that the users, or the customers, of course that's the right word, are actually the doctors in university hospitals, where apart from doing the doctor's regular tasks, they also involve into doing serious research. So I think in India also there are a lot of places like that. And So and other type of customer will be university, biology, people who are doing radiology research, preclinical. So first of all, preclinical here means that before clinical, before human. That means we know that basically the lot of animals, small animal like rat, ferrets, these mammals are used as a human analog. Like we want to study certain drug, whether it works or not on the body, or fighting a certain disease or not, and people use the rat and the small animal, and there is an established practice that what you study or what you come up with, the lot of innovation here in the small animal, that can be translated to the human body or human diseases. And that's why translation word is used, that it can be translated. Anyway, so you can see in the logo, and behind that, below that itself, it shows that ultra high performance synergistic means they are talking about synerging various modalities like PET, SPECT. So PET is about, we know that it's basically a nuclear medicine tomographic imaging technique which relies on positron emitting radionuclide, where positron will emit the 2 gamma photon which will be traversing in opposite direction, and then detector will detect that, and then from that data people will do some functional imaging. Functional here means basically the injection of a certain radiopharmaceutical that will be absorbed into the body in a functional sense. Like you want to check a certain disease, or you want to study a certain type of cancer, then you will have to inject a certain type of chemical, so that's how it is called functional imaging. Similarly, SPECT is also functional imaging technique, and here it's all about emission tomography. That means, so you inject inside the body a certain chemical, and then that will be absorbed into the certain desired part of the body. Here of course we are talking about a small animal, and then it will emit gamma ray from the body, and then the detectors are basically will detect that. So that's why it's called emission tomography, because it is emission, the gamma rays will be emitted from the body itself. Whereas on the conversely, there is transmission tomography, which is CT here, and where basically you'll have a source, or the X-ray source outside the body, and then that will go through the body and you detect on the other side of the detector. So that's the difference. And optical is actually functional imaging again, where people use bioluminescence property and fluorescence property of the human or here of course small animal body. So their goal of the whole company, or if you see the products, you'll see it's about packaging these different technology, not drastically different, because PET, SPECT I will say is in the same spectrum. Optical of course is different because physics is different, and CT I would say it is again maybe mathematically or computer science point of view it's a little bit different, but again it's gamma radiation there also, or X-ray radiation actually. And the product is about bunching all this technology together into some sort of platform, and yeah, so that's how they do that. And yeah, and that's the idea of the product. I mean it's not like a patented thing that that they will combine all these things, because that's the very simple thing. Most of the people, other similar company do that, but we'll see. And in the last week's video also we saw that how so their core IPs are all in innovative collimation design, and even the SPECT or PET which we see here, that will also work on collimation, which is not the coincidence. So these are a lot of technical detail, but what I'm trying to mean is that so the key to building a company is, I would say, is to secure some VRIN of your team. That means the scientist and engineer that you hire, and and use that VRN to generate IP, and the core IPs will decide what will be your product. So here last week we saw the IPs, and now here we are trying to understand, depending on those IPs, how they are actually innovating onto the product and how they are marketing it into the customers, actually, that the doctors and the biology researchers, So that's why the first part of the video will be at least on that. Now here we see again they are trying to market or trying to portray the message. That is the more appropriate word here, because it's not like the products are not like the mass level thing that everyone is buying from the store or something like that, but rather actually they are building the machine which will do the research for the other group of people. So it's like that, Okay, so the same thing. So in the previous slide we see the PET, SPECT and optical imaging and CT. Now they are showing, giving the same message into a different figure, where they are showing synergistic imaging, ultra high resolution, any combination, many unique features. Bioluminescence, that's part of the optical imaging. Fluorescence, that's part of the optical imaging. X-ray, CT we saw, SPECT, PET, and then rest of the things are like vector, CT, PET, SPECT, and that's actually they are one of the product. And I will just give you some more detail about it also, that it's not like that everything here is actually a new product or something, but rather it's like a functionality, what you can do, like using their optical platform. You can use fluorescence, you can do fluorescence, bioluminescence imaging. Nuclear microscopy is actually most probably about using their collimators. So all their products actually comes with a range or series of different collimators. So depending on the isotope, depending on the type of study that you want to do, you want to choose an appropriate collimator actually. And nuclear microscopy is actually a fancy word, of course, and basically it's about imaging in a high precision, that means high resolution. So there are also some dedicated collimator that you want to use. So anyway, high energy PET basically means PET isotope have some extra high energy gammas, so you can image that, and that will give you some interesting features. So again, I don't want to go into the technical detail. High energy SPECT, same thing. 4D, 3D, 4D, fluorescence, CT. 4D actually means getting the image with time stamps, like maybe at this time point we get this image and all this thing. And of course there is an extreme thing, like people talk about you can slice the time and get more information, but of course at the cost of getting bad image, because if you slice the time for a small thin slice, then you get not too much of data. So yeah, don't want to go into the details. I'll just touch upon for example, X-ray angiography. We know that it's actually blood vessel imaging. So I would say, since I'm not a person from X-ray background, but there is a spectrum of technologies from the X-ray side using dual energy X-ray, I think, which is DEXA, I think. So where they use the two energy of the X-ray. So in other than emission tomography, X-ray basically is a transmission, and they are in the X-ray tube. You can, depending on the voltage, it can produce different level of different energy X-ray. And X-ray is nothing but gamma radiation with less energy, let's just say, in that sense. Radiography, which is yes, a lot of time they do, small animal, they, after to get a very good image, they do actually it sounds very weird, and that's a established technology, and that's actually they froze the animal. It already injected with some radiopharmaceutical, and they get some image, and now they want to cross verify or get more detailed information. So they kill the animal, and they of course in some ethical way, and of course and they froze the animal with the liquid nitrogen, and then they slice, or like a bacon, they cut the animal at separate slices, or maybe if they are interested in to study certain organ, then they take out the organ, then they froze it and they do some imaging. So and so autoradiography, I think they do this slicing, and then it can produce huge, I mean, extremely good quality image actually of the functional quality, like, you know, yeah. And in the, yeah, here also you can see that the products that they have: USPECT CT, UPET, and Vector CT, UOI, UCT, E-class mean economic. So they have a certain direction of research where they are trying to reduce the cost of the whole equipment or this product by changing certain thing, like maybe director area, and not too compromising on the output of the product, like, you know, resolution and etc, the quality of image, etc. Now here, yeah, if you are interested, you can go into that, but that's not the kind of video here it is. But I will try to portray here, although you see the product like USPEC CT, UPET CT, Vector, UI, UCT, or at least the first three in the left side. These are not actually, indeed not actually extremely different or totally different. It's actually same sort of technology from a physics point of view. Rather, it's about using different collimator that I talked about to zoom into or certain experiment, or if you are focused into PET isotope or high energy, then you use certain collimator, etc. But the design wise, the scanners are almost same, and maybe vector scanners are actually more mature, more there better innovation done here, because historically USPEC comes first, and then UPET is basically I would say similar in the spectrum, but it's just a marketing term actually. But physics wise, technology wise, these are almost in the same spectrum, with a certain thing here and there, that basically it's a company with a lot of scientists and engineers doing research, and they have a group of research who are doing research continually in the hardware as well as software domain, and then and the CEO of the company will make a decision that, okay, so this is what we understood, so let's make a new product, or in the new product we will market in this way, and these are the new thing we'll do in the software as well as hardware. So that's the way it works. And of course UOI, and these are actually optical imaging. So I saw their product also. So they have, like, I mean, depending on the customer, they can make you, like, it's not like all the optical spec all will be combined. So that's the whole product, and that will be more expensive. But if someone is interested in buying into optical only, then that can be also a product. So they have all this option. Along with that, animal handling, they also have like a lot of interesting product, which I will say ancillary product. Like, it's not like the product by itself, but rather to use the whole the main technology, you'll have to have this smaller equipment. It's more like if you are buying a bike of a certain company, let's say Honda or something like that. So now you need to buy, I'm not a bike guy, but still, you know that you need to buy certain extra thing, some to do extra stuff, who knows, like buying a helmet or maybe some guard, or who knows. So here also, to perform to use this product, and that means you performing different type of experiment, you will be using certain animal, etc. So animal need to be anesthetized, and how you do that. So all this range of baits come, and then the baits have a lot of interesting feature, like the temperature control, so that the animal can sleep well, because if it is moving, then you can't really perform experiment. Then the anesthesia, comes into the picture, how you do the anesthesia in the right way. So all these are actually electrical as well as electronics, mechanical engineering, electrical engineering coming to play actually, you know. And nonetheless, other last thing I would want to focus is for software platform. Now, of course, all this about imaging, etc., etc. So you need some acquisition software and image reconstruction, which will make sense of the data, etc. But now we get the feeling that, you know, all that, oh yeah, I mean, the hardware is the everything and this is there, etc., etc. But the software, or even the before, at least in innovation in this kind of technologies, people use mostly software to research onto new design, etc., etc. So that is one end of or one direction where I want to show you how the softwares are important. Now, of course, from the customer's point of view, what they will see in the software is basically some feature in acquisition, some feature in reconstruction, etc., and versatility and a lot of freedom to operate on, you know. But these are equally important, this software development, how you make sense of the data, and there is huge amount of literature, huge amount of community doing only this thing. So these are also important for the any company's product, that how you portray things and how much amount of proprietary property you want to how much you want to show. You know, for example, in this kind of company, they all have a certain level of thing, like, you know, I don't want you to go into the data you can't see the data or from the hardware. You can see only data till this point, and you can't. So what I'm trying to say is that there are a lot of encryption that, you know, they don't want to let go of a lot of interesting feature they have actually, or like age they don't want to let go of a lot of interesting opportunity of development that they want to do in future. So they don't want to give you the full access of a lot of things. So software is or GUI software is the best way to package a lot of core technology, not here hardware sense, but the software IP sense. And you can package it, and then GUI, you just click it here and here, and then you plan or design the software in such a way that it gives interesting amount of freedom to operate for the users, that means customers, and that's it. And in fact, we also, for this company, we saw like mostly the hardware IPs, but there are cases where you will see a lot of software IPs, which are equally important, I would say. Here we can see the examples, the products and their feature. So in case of Vector City, which is actually recent product, or at least the newer one, and there you can see how they are marketing it. The highlight of the product, like, you know, integrated high performance PET city. Use PET, they haven't actually used PET, because PET basically means high energy, and for that they need a special collimator, which they had not generated that time. So that's why. So what happens generally in a company, like, you know, okay, so they do some research, a lot of 2, 3, 5 years of research, and they come up with some interesting product, not like the product, but rather some interesting technology or interesting part of the existing technology, and they understood that, okay, so changing this design into something like this will give you extra advantage. Now there is 2 options from there. With the same product, they just say that, okay, we have done that, but they can just name it into different product, and they can have a new product and market it in more better way. So that's why the name Vector and etc. comes into the picture. And UCT is ultra high CT, and UOI is ultra high optical imaging, etc., etc. So yeah, so again, I'm not going to go into the detail because that will be technical, which will not be interesting for everyone. But the idea here is to touch upon the product related, the macro views one can draw from these examples, Now here, they are actually, for all their product, these are they are highlighting what you can do with their product, like, so breakthrough translation resolution. Translation word is used as like you are translating some technology or some understanding on some experiment on the disease into preclinical to clinical. So that's why they use, and I don't know exactly why they call translational resolution, but anyway. And in this domain, the product, you always want to come up with some number, like this is the resolution, this is the uniformity of the image that you will get, this is the sensitivity, this is the resolution of the detector, etc., etc. Resolution of the detector doesn't make sense, but anyway, that's not the output, ideal output for the medicine people. But anyway, here also you can see that PET without positron range blurring elimination, for example, this using this isotope. Sorry. And yes, theranostics spect at less than 1 millimeter for all radiotherapy isotopes. Yeah, I mean, these are more marketing term, but I mean, that's what they are doing here. So breakthrough translational resolution, unlimited theranostic research. Theranostic means basically where you basically use radioisotope to do therapy as well as diagnosis. So there are a lot of these kind of isotopes that are used, and there is a need in the preclinical research domain to, they understand what should I say how we can plan what should be the right plan of therapy, and what is the protocol, and depending on the potential chemicals. I mean, I use this chemical word in a very general sense because I'm not a student of chemistry, but I think I should use some sophisticated, more educated words. But anyway, but depending on the pharmaceuticals that you are proposing, which one will work in which way, and whether those are good or not. So that's a huge question. So there is huge amount of research going on into theranostics, and so they also need imaging, mainly functional imaging. Higher sensitivity 4D imaging. Again, I said 4D basically means that you use the time as a frame, like now you are doing or maybe 1 hour later you do it again, imaging, and see the changes. That's basically 4D. And of course, their multimodality thing they want to highlight here. So that's the point here. Okay, so I decided to, so as I have planned basically that we will be looking into some similar company and do this similar sort of patent landscape analysis for that company, but it turns out that it's not that easy to find a similar company, because different company have different, I would say, marketing strategy and access to or focus on different type of technology, I would say. So for example, here I am showing you some name of certain small as well as big companies, and when I go into their product portfolio, we can see, I mean, first of all, let me be honest that I don't I know bit about MI Labs, but I don't know about these companies, and certainly not all the things about their company is disclosed, and or maybe because I know bit about MI Labs primarily due to my job here, and but these companies, yeah, I mean, it's hard to get exact detail, and of course in the Google patent, if I search, then there is a lot of diverse sort of patents and not easy to come up with a the desired similar kind of landscape analysis. So I decided to do it in different way, and in short, basically I will try to cut it short and try to get to the conclusion for the exercise that I'm dealing with here. So yes, but good to know here that just like MLabs, which is the product company which produces preclinical scanners, PET, SPECT, optical imaging, and etc., and CT, of course. Similarly, this company produce, for example, Molecubes is almost similar company from Belgium, I think, and Mediso, I don't know exactly, Bruker, I also don't know, and Siemens and Philips, these are global companies that we know, big companies, and they have, I mean, the healthcare part of is a part of their company, but then it's a huge company actually, Philips as well as Siemens. What should I say? There is something I want to tell also. So this is something I want to tell, that each company, especially these smaller companies, they have they generally start as a startup, and then or maybe in some conventional companies also, maybe, or different ways, but the survival for that particular company depends on the expertise of the people working in that company on a certain focused technology, and how they mold or design the product or plan the product which uses that technology efficiently. For example, MLabs is actually pinholes, different design of the pinhole that gradually make them break through into the market in terms of maybe price, and that I don't know specifically, but certainly they are successful as a company. So similarly, Molecubes, they also have some USP in their product, like certain technology, certain part of it, they had a good expertise, and etc. So that is what I want to tell, that in case of a smaller company, it is always a certain understanding, and not just the fact that they have the IP, but rather people working for longer time on that company, they have greater grasp on what should be the next step, not from the scientific point of view as well as scientific cum business point of view, like what technology will be successful in the market. They have a good gauge on that, and it's not an easy task with all the expertise and with all the education of MBA and even the core scientist. It's not easy to grasp on it. It takes time, and I think it's a more of a byproduct of a experience, I would say. So anyway, so that's just my thinking. So now in the next slide, I'll just give you the VRIN, that means the valuable asset of the MLabs, and then try to explain what can be the new product. Or let's not talk about the new product, because I'm just a very simple guy to even thought about it actually, because that's a big step, but rather say that what will be the innovation in the existing product, or what will be the direction, if I am allowed to say that, what will be the direction of the company, what will be the direction of the research should be, etc. So in the next slide, we'll just touch upon that, and then we'll end this exercise, because I feel like we want to move on, because we don't want to be too much go depth into this, because I have a bigger goal of reading and finishing this particular book on the lecture series that I'm making here. So yeah. Okay, so all this built up to something which you may not like personally, and I can only point out few things here. What are the VRIN? And I would say that the main VRIN of this particular company is the various collimator design IPs that they hold, and the upcoming time they also going to have a lot of interesting design. I'm not saying certainly there will be competitors, but I would say more important VRIN will be VRIN would be researcher experienced in doing that. That means the people who are designing this collimator, the company people, or maybe the collaboration, whatever it is, they are more valuable people, and of course the company is doing more of a business oriented task and various other things which are equally important. But as far as core technology upon which the whole business was set up and successfully is running, is I think is the design of the collimator and the innovation that the collimator can be designs can be improved, and all this thing can be it can be used to do the multimodality imaging, like SPECT as well as SPECT, and etc. That is the core value. And as far as the new product idea, I would say that that's a bit hard for me to say anything about that, because I'm not that kind of I didn't do that kind of a rigorous study, because that would take a huge amount of time, and we don't want to go into that too much of detail. As well as we can think about what are the how to improve the existing product and all these things. So there are a lot of things one can do, and I would say the software side will be interesting to look into. Like there are a lot of specific domains where you can try to produce software solution which can improve the performance of the product, for example imaging, performance, and etc. That is the core thing. And of course service side, that's I think in these cases, of course, service side is not that hugely important, because these are the product basically used by researchers actually. So since so now these are the 2 points I have for the new product idea, or whatever you want to say, or maybe some advice, which is like a small person trying to teach a big person, or the wise person. But anyway, I would say that since their core value for the company is the expertise in making innovative collimation, etc, I would rather, because I would rather focus on ways to find, or R&D on economic way of manufacturing various collimators, because if you can do that, then because by changing the collimator you can use the PET imaging, you can do the SPECT imaging, etc. So that's the valuable part, and the user and customer will have to buy a lot of collimator. And then of course if you can build collimator in an economic way, maybe, who knows, like different ways nowadays, 3D printing and etc are moving ahead, but I don't think that would be easy, because although there's a lot of hype about additive manufacturing, all this thing, but still it depends on the material, and certainly here with the complex design and etc and the precision that had to be maintained with the design and etc, it is not easy. But still I would say maybe putting some effort into finding those ways, because if they can find way to make the price down for the manufacturing of the collimator, then the customers can buy more range of series of collimator, and then using that they can do different experiment. And that's the core of the technology, I guess, that they talk about different ranges of collimator, and then in fact they have collimator sheets and all these things. So anyway, certainly putting human resources, that means making the the existing experienced person in the company, or maybe the collaboration, let them do innovation into that domain and come up with custom design for each application. That means let's say I'm doing some therapy or theranostics of a certain isotope, so I want the collimator to be made in this way. So or who knows, like maybe making collimator which can mechanically change itself, I don't think that's quite a stretch of imagination, but who knows, maybe it is possible, who knows. So that would be my advice, or whatever way you want to take it, new product idea or improving existing product. But anyway, I don't want to go into the new product design because that will be too complex, but yeah, that's the conclusion. So yeah. And as usual, this is the reference of the book that I am talking about, from where I'm making these videos, or the product design and development book, and this is the web link from where you can download it. So yeah, so that's it about this week's video, and that will be the end of the particular chapter that we are studying, and then from the next week we'll start the next chapter. So see you, and see you in the next week. Yeah, bye bye.